steps to make a string palindrome. So we are giving a string, and we want to calculate the minimum insertion steps. So for example, for this string, the minimum insertion steps are going to be 0 because it is a palindrome. And for the second one, as you can see, m equals to m, b not equal to d, so the minimum insertion is going to be 2. We can insert a b at the right side. Yeah, we can insert a b at the right side, and we can insert d at the left side. So for example, let me make it m, b, a, d, m. Yeah, we can insert b here, and we can insert another d here. Yeah, so this is gonna be a palindrome, so the insertion is gonna be 2. Yeah, so if the testing case, according to the testing case 1 and the testing case 2, normally this is for checking the longest subsequence. Yeah, so there are gonna be 2 ways. So one way is for calculating the longest common subsequence. So for example, for this one, let me make it clear. Yeah, so for the first one, so for the second example, I'm going to use this example. So for example, we have MB, A, D, M. And we want to check the longest common subsequence. Normally for a palindrome, if we reverse it, the sequence is going to be the same. So we just reverse it. So it's going to be M, D, B, M. It's going to be M, D, A, B, M. As you can see, this M equal to this M, and this B, D not equal to B, but it is okay. Now, this is going to be 3-1, and this is going to be 3-2. We're going to compare with 3-1 and 3-2. They are equal, and they are not equal for this BD and for this DB. So the longest common subsequence is MAM, so it's going to be 3. And the final answer is going to be the length of the string, 5 minus 3. It means we're going to need 2 insertions. Yeah. Now let's first solve it like a longest common subsequence. So normally for me, I'm going to define a LCS. So inside it's going to be 2 strings, S1 and S2. So I'm going to prepare R and C, and going to be length of the S1 and length of the S2. Yeah. So currently it is the longest common subsequence template. Yeah, we just need to prepare a DP. So F should be equal to 0 times 0 times C. So for R in range capital R, and then we're gonna check it. So for R in range 1 to capital R, and for C in range 1 to capital C, we're gonna check it. So if S1 R equal to S2 C, so this means if they are equal, so we're gonna so if they are equal, we're gonna check the previous value. So it's gonna be FRC would equal to FR minus 1 with the C minus 1 plus 1. Because they are equal, definitely we got a length of 1 and plus the previous ones. Yeah. And if they are not equal, so FRC should equal to the maximum, because we are checking the longest common subsequence. So it's going to be FR minus 1 with C, and FC FR with C minus 1. Yeah. So that would be all the cases, and finally we're gonna return F0 to finally we're gonna return F minus 1 with minus 1. Yeah. And then we're gonna call the function, and it's gonna be longest common subsequence of S and with reverse of S. Yeah. So basically this is the pattern for solving the longest common subsequence. And basically we're going to prepare a 0 for for the 0 row and 0 column, we're gonna prepare all this to be 0. This is just a padding, and then from the index 1, we're gonna tag. So for this index, if this is A, and if this is A, if they're equal, so we're gonna use this one plus the value before it. It's gonna be 0 plus 1. It's gonna be 1. Yeah. Now let me just run it to tag if it works. But it should not work because I forgot to use the length of the string as minus the longest common subsequence. Yeah. Yeah. Let me just run it to tag. Something wrong. Yeah, it means the difference is only 1. It means I forgot something. Yeah. Let me just check it. So here it should be 1. If they are not equal, I'm gonna check the longest. Yeah, I think I forgot about the longest common subsequence code. Yeah, basically it is the row and column. So this is for column, and this is for rows. And from the beginning, I set it to be 0. Yeah, and now I'm gonna check it. So if they are equal, so FRC should be R minus 1, C minus 1 plus 1. Otherwise, I'm gonna check the yeah, I'm gonna check the maximum of the two, I believe. FR minus 1 with C. I think I did it. Yeah, it is FR minus 1 with C and FC minus 1. Yeah, let me just print out this F minus 1 and minus 1 to check the longest common subsequence. Yeah, I get a 1. It should be. Yeah, let me just check the print. I print out a 4. It should be 5 because the longest common subsequence for the first example should be 5, but I get a 4. Let me just check that. Maybe I'm gonna set a 1. I'm not sure. Yeah, I need to set a 1. Yeah, I think I need to do it basically like this. I need to, if I were to prepare padding, I should always prepare padding. And if I put a 1, it is okay. But for the normally for the normal solution, I'm gonna always use a padding. And this is just because I forgot to use the padding, and it should be 0. And here the length should plus 1, and f2 should also plus 1 because I need a padding. Yeah. Now let me just run it. It goes out of the index because here should be R minus 1 and C minus 1 for the string because I'm starting from 1. Yeah. Now let me just run it to tag. Now it seems it works. Yeah. There may be different ways to write in the longest common subsequence, but I prefer to write it like that. I always prepare a padding, and then I'm going to prepare the DP array, and I'm going to start in from index 1, and I'm going to have a if-else tag and get to the final result. Now let me just submit it to tag if it works. Now as you can see it works, but it is not so fast because this is not the best way to solve such problem. Because this problem is not about a longest common subsequence. You don't need to reverse it, compare two together. Basically this also takes time. Yeah, because this is basically n-squared solution, but it is okay. Now we're going to use another solution. It's going to be the interval DP. Interval DP, we're going to solve it directly from the left side and the right side. So this is going to save us half of the time. Now let's try to use this kind of a method, and we're gonna prepare a case. Yeah, let me first explain how can we solve it. So if we have a character string like ZZAZZ, this is gonna be the first case. So this is gonna be I and J, and we're gonna check from the left to right side. So this is the interval dp. So I'm gonna check that if they are equal, so it is okay. So I would be shifted here and J would be shifted here. And if they are equal, it is okay, I to here, J to here. So if the position I equals to J, and definitely I gonna return 0. So this means the final result gonna be 0. So in this way, I solve the problem directly. I didn't solve the longest common subsequence and then use the length of the string minus the longest common subsequence. Yeah, but for this problem, I want to solve it directly by using the interval dp. So let's just check the second example. So for the second example, we're gonna use this one. Maybe it is better to explain. Yeah, if we have this m, b, a, d, m. So we're gonna check the first one. This is okay. It goes to b and d. But what if they are not equal? So that is the second case. So if this b not equal to d, so basically there are gonna be two ways. We can try to insert a b. It means we're gonna insert a b. So we're gonna plus 1. So the DFS is gonna become a to d plus 1. Or we can also insert a d from the left side. So this means we're gonna consider this b and a plus 1. So it's gonna be the sub-problem is gonna be and DFS ba plus 1. Yeah. Now let's try to solve the problem. So we're gonna define an DFS. It's gonna be I to j. So if this I more than and equal to j, basically there's no such case. It's gonna be a single character. It is okay. We're gonna return a 0. Or if there's no character, we're gonna return a 0. Yeah. Now we're gonna check if they are equal or not. So if si equal to sj, yeah. So if they are equal, so this means we're gonna check the subproblem. So the subproblem is gonna be I plus 1 and j minus 1. Yeah, it is okay. So else, if they're not equal, so I'm gonna yeah, so if they are not equal, because I'm gonna check the minimum insertions, so I'm gonna check the minimum of the two. So it's gonna be DFS I plus 1 with j, and DFS I to j minus 1. But either way I used, either it is I plus 1 to j or I j minus 1, definitely I needed to use one insertion, so I need 2 plus 1. But I want to check the minimum of the 2 and then plus 1, because my final result is going to be the minimum insertion steps. Yeah. Now I just need to call the function. It's going to be DFS from 0 to length of string minus 1. As you can see, maybe this interval dp is going to be much easier than the longest common subsequence. Yeah. Now let's just check that. Yeah, as you can see, it works. Now, let me submit it to check. As you can see, it passed all testing cases. Definitely, this is going to be a little bit faster. As you can see, there are going to be two ranges. One range is in this areas, a lot of people, and this is another range. Because in this areas, I believe it may be using the DFS plus a memorization. And maybe here, they just use the tabulation, I mean the real DP, dynamic programming. Yeah. Now let's try to use the dynamic programming to check if we can raise in these areas. Yeah. So we just need to translate the DFS with memorization to dynamic programming. So we're gonna prepare some. Yeah. Let me prepare n should be equal to length of the string and prepare a DP table. So f gonna be 0 times n for r in range n. So this is going to be the DP table. Now I'm going to check it. So for I, so this is going to be a bottom-up DP. So it's going to be n minus 1, minus 1, minus 1. And for the j, it's going to be I plus 1, because we need to check the range from I to j. So the minimum distance is going to be I plus 1 if this is n minus 1. So n minus 1 plus 1, it's gonna be n. It is okay. But if this is n minus 2, so n minus 2 plus 1, and it's gonna be n minus 1. Yeah, so I to j, n minus 2 to n minus 1, so it is okay. Yeah, n minus 1 to n, so this is n minus 1 and n minus 1 plus 1, n minus 1 to n. This is okay because the minimum distance is 2, so it is okay. I plus 1 to n. Yeah, now we are going to check that. So if Si equal to Sj, so what are we gonna do? It is from here, so it's gonna be directly gonna be dfs. So we just need to use dp. So it's gonna be Fij should equal to Fi plus 1 with j minus 1. Yeah, else they are not equal. So Fi and j are gonna be the minimum of the two. So definitely it's gonna be Fi plus 1 with j and Fi to j minus 1, and we need one insertion, so we need a plus 1. Definitely we just translate those two lines and to be here, and it should be okay. Yeah. Finally, we just need to return this f0 to n minus 1. We just need to translate this line. This is n to 0 to n minus 1. So here 0 to n minus 1. Yeah. Now let me just run it to check. As you can see, it works. Now let me submit it to check if it can pass all testing cases. Yeah, now as you can see, it passed all testing cases and it reads in this area. Definitely in this area they used the dynamic programming, and in this area they used the DFS plus memorization. Thank you for watching. See you next time.